Okay, so we've got a squared plus b squared equals c squared. In other words, the square over two shorter sides add up to the square of the longer side. So 10 squared is 100. I do that way. And 18 squared? Anybody help me?
324.
Sorry?
324.
324?
Yeah.
So here we got 100 plus 324. What's the square root of that? The square root of 424. Okay, we want to leave our answers exact. Okay, so we have a radical. Can we simplify this one though?
Yes.
Yeah.
How can we simplify it?
2 and 6.
2 and 6.
2 and then 6 in the square.
Well, how'd you get 2 and 6?
Oh, never mind. 24.
Yeah, 424. So this is the same as 4 times 106. Right? So square root of 4 gives us 2. Square root of 106. We can't do anything with the 106. Okay? So that gives us the length of that side. Now, the somewhat tricky part is how we get the angles. How do we get the angles on this one? 10. What about 10, Sean?
You have to find the opposite side of the adjacent.
Okay, which was the opposite, which was the adjacent?
I don't know.
Did you do your homework?
Yeah, I did.
Okay, so how'd you figure the opposite over adjacent for your homework? Boy, it was a good long weekend?
Yeah.
Okay. Who can help Sean
I did
remember?
like Thursday, so.
Okay, who can help Sean remember? Nick?
The opposite side from where the angle is, so this side likes the other side.
Or which angle?
Well, the 10 of theta could be either one.
Yeah, I mean, here you just define which angle you want to solve for. Right? So here we can say that, well, we want to solve for theta over here. Right? So tan of theta.
So it doesn't matter.
Is what angle that you're trying to solve for. So it does matter
No, I mean, what?
for which angle you choose,
Yeah.
which one you want to solve for, right? So here we got tan of theta is what? Opposite over adjacent. So tan of theta is, what's the opposite here? 10. And the adjacent is over here is 18. So we got tan of theta is 1.8. 10 divided by
0.55.
I'll just leave it as a fraction for now. Divide by 2. 5 over 9. So I want to solve for theta. Right? So I want to do the opposite of tan. What is the opposite of tan again?
10 minus 1.
I didn't learn. Bleaching.
Oh.
Yeah, inverse of tan. So inverse of tan theta. So we take the inverse of tan of both sides. So theta is equal to, so what's the tan inverse of 5 divided by 9? Like 29 point.
29.05.
These are decimal, we'll make it a
Okay. I didn't specify the nearest, usually be to the nearest degree, or maybe to the nearest 100. So here we say theta is equal to 29 degrees. Okay? Well, what about alpha? If I say that's alpha, what's alpha?
You can do the whole thing again, or you can have, you know that all triangles, all the angles add up to 100.
Right, so all the angles of a triangle add up to 180. So we get 180 minus 90. Remove 180 minus 90, minus 29 is
61.
61. However,
Sorry, we learn from our mistakes.
I would not recommend doing that way. Well, you can assume, let's say this question was out of 3 marks,
2.5.
right?
Yeah, but this,
So the 3 marks are for the side and your 2 angles. I know we're all really good at calculators because I've seen it in the past. You guys can punch in the numbers really well and, you know, hit that square root or whatever. But let's just say you make a mistake with your calculator and you got theta is equal to 25 degrees, 19 degrees. I don't know how you can get some of the answers you guys get with your calculators. But let's just say it's not 29. Let's say you got 19. Then he says, you know what, alpha, that's 71 degrees. If I was mean, I'm going to give you 1 out of 3. Because basically you got theta wrong, right, for some reason. And then because you got theta wrong and you used the 180 degree rule, you got alpha wrong, right? I would just say take a little bit more steps. So that's almost like checking while you're working, right? I would do, well, what's the tan of alpha? Tan of alpha is, in this case, what would that be? So tan is still opposite over adjacent, right? So that hasn't changed.
yeah, it's,
Tan of alpha is, yes, Nick?
I just have a question. When you what's the like when we're using our calculators, you know, we always get like a big, like a lot of decimal places. Do you want us to just use that number exactly or just round it in?
Well, it depends. In this case, I didn't specify, but we would specify like the nearest degree, the nearest hundredth, right? Okay, so then you would just have to do some rounding there. Okay. So for tan of alpha, what's opposite over adjacent? What's the opposite side now? It's 18 over 10. So it's 18 over 10. So now we want the tan inverse of tan of alpha. So we're going to tan inverse of 18 over 10. So what's the tan inverse of 1.8?
Not exactly, but 60.945.
Okay, so 60.94. So we can say that, yeah, that's roughly around 61 degrees. Okay? So chances of you making the same mistake on your calculator twice is less likely, especially if it's just a punching error that you would make. Okay? So I just recommend this method. Okay? It doesn't take you that long to actually figure out the tan.
So if you did it with the 180, would you still get full marks?
If you got it right, yes.
Yeah.
Right? If you got it wrong,
Yeah, I know.
because I told you this, it's in your notes now. I'm suggesting that you actually figure out the tan of both angles. Just as a double check you got the right answer. And easy marks. I just see it as like easy marks. Questions on that? So I mean, this is basically review what we did last class. Tangent. Figure out the tan of an angle. So today we're going to start something somewhat new. Some of you might have heard this before, SOHCAHTOA. I always thought when I first heard it was some like Indian god or something like that. Indian trigonometry god. SOHCAHTOA. Okay. So this is a triangle that I left over from the tangent notes. Let's just write SOHCAHTOA. Draw this triangle again. So we did our a squared plus b squared is equal to c squared. This was the square root of 117. I think Eric said that we could simplify that. If we reduce that to, was it 9?
It's 3,
3 root 13. Okay, so we know the length of that side. So again, what's the tan of theta? Opposite over adjacent. So in this case, it's 6 over 9. Or is it with 2/3? So what we're going to do is introduce another two other trigonometry functions. One's called the sine of theta. Okay? So here again we have sine of theta. So sine of theta is opposite. Okay, so the same as tan. And now this is over the hypotenuse. In other words, opposite over adjacent, or opposite over hypotenuse. So here in this example, sine of theta is what?
6 over.
Yeah, 6. So the opposite side.
3 root. But would you
Oh yeah, 3 over root 13. Which is same as 2 over root 13. So what was tan of 2/3 again? So we put that in the calculator, tan of 0.6666666666666666666.
7.
Yeah.
Tan of 0.666 is 7.
Yeah, so it goes from 6 times and then goes 7.
But what's the tan of that?
0.01.
Sorry, the inverse tan. Inverse tan of 0.666666666.
33 or 34.
34 roughly?
Too much.
See anymore.
So what in your calculators do, 2 divided by square root of 13 and take the sine, inverse sine of that. So again, we have the opposite of sine, which is the inverse of sine. So take 2 divided by square root of 13, that number, and take the inverse sine of it. What do you
Somewhere
get?
around
Yeah, roughly 34.
34, you get the same angle. Okay, so there's multiple ways you can actually figure out the degree of that angle. The last trigonometry function is the cos. So again, this is opposite.
It's adjacent.
Oh, sorry,
Adjacent.
it's adjacent. Thank you. So cos of theta is you take the side that's adjacent to it, and here you divide by the hypotenuse. So in other words, adjacent over hypotenuse. So in this case, the adjacent is 9 over, the hypotenuse is 3 root 13. So that's the same as 3 over root 13. And now you can do the same thing. Take 3 divided by square root of 13, take the inverse cos of it. And hopefully you should get 34. Okay? So basically 3 equations you gotta remember. And that's where SOHCAHTOA comes in. Okay, is everybody need to finish writing that down?
So, couldn't you use the actual square root of a hypotenuse of 1
Yes. To get your angle?
Yeah.
Yes. So that's what we did here. We did 2 over the square root of 13,
Yeah.
taking the sine of that, we got 34. Took 3 over square root of 13, took the inverse cos of that, and we still got 34. Okay? So the SOHCAHTOA is short for sine is opposite over hypotenuse. So that's where we got this from. So this is sine is opposite over hypotenuse. The cot is cosine is adjacent over hypotenuse. And then your TOA is tan is equal to opposite over adjacent. Okay, so that's sort of like the trick of remembering those trigonometry functions. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And what you could do is you could play around with this triangle. So you could call it an angle alpha. And you could do a whole bunch of tans, cosines, sines, or inverse of them. And you'll get that should be 56 degrees roughly. Okay? That's all it is to trigonometry. It's just understanding where you got your angle and your relationship to your sides. Of course, this is all caveat with your triangle has to be what? Yeah, it has to be a 90-degree angle for these trigonometry functions to work. Okay? Nick?
You mentioned those in your calculator, the 2 over root 13. You just do that.
Yeah, so you just 2 divided by root 13 and then you take the inverse sine of that.
Okay, so that